Problem 3, an archer fires a flaming arrow at a crowd of invading robots. Same as the other two problems. The first thing we do is break this into its component parts. Then you have to find time. So, once again, component parts and find how much time the arrow is going to be in the air. I'm using the quadratic equation again. Here you have the formula set up just like we do on our note cards. The only thing we don't know is time. So I set the formula equal to 0. I showed you how to do that. And then you have A, you have B, and you have C for our quadratic equation. There's a quad. And we land up with either -0.32 seconds, negative 0.32 seconds, or you land up with 17.6 seconds. I was surprised to find out how long an arrow would go, but you have to consider there's no air resistance in this problem. So that's really unrealistic. Part B says, what is the distance downrange the arrow will go in the x direction? And we land up with distance is equal to velocity in the x direction times time, and land up with 1,494 meters. Part C says, what is the maximum height of the arrow? Again, if you let the velocity final in the y direction be 0, that means the arrow goes up, and imagine the arrow stops there, which it does. You're just analyzing for that part of the equation. You plug in the numbers here, and you land up with the arrow going 368 meters high. And finally, D, at what speed does the arrow hit the ground? You have to find out what the velocity final of the arrow is in the y direction. And we land up going negative 87.6 meters per second. That's our hypotenuse, that's our y leg of a triangle. We know originally we found out again that it was 84.9 meters per second in the x direction. We found that way over here. Again, our velocity in the x direction does not change. Simply use the Pythagorean theorem. The hypotenuse is equal to the square of both legs added. We landed up with 121.6, so that's the value there. The arrow is going 121.6 meters per second. And what angle is it going? We use TOA of SOHCAHTOA. Rearranged as theta is equal to the inverse tangent opposite over adjacent, and we land up with a 44.1 degree angle, you can say to the right of the y-axis, negative y-axis. As long as you draw the triangle and show the numbers, it works.